Let's now learn about a new mathematical tool that will allow us to sketch three-dimensional surfaces in space. This mathematical tool is called the trace. A trace of a surface is the set of points at which a surface intersects a plane that is parallel to one of the coordinate planes. Another way of describing it is like this. A trace is the line of intersection created when a plane that is parallel to one of the coordinate planes intersects a surface. Let's look at an example. Let's look at some traces of a sphere. Suppose we have some sphere of some radius. We'll say this sphere has a radius of r. Let's now suppose we have a plane that is horizontal to that midsection of the sphere. Or not horizontal, rather. We'll say the plane is parallel to that midsection I have for the sphere, to this region of the sphere. Well, this plane is infinitely thin, and imagine that this infinitely thin two-dimensional plane is moved such that it slices part of the sphere. So we'll move this down such that it slices this part of the sphere right here. Notice what's produced there. In slicing the sphere at that point, we end up producing a trace. If we were to actually look straight down, if our vantage point was up here and we are looking straight down on the sphere, you would see that where the plane sliced the sphere would look like a circle from that vantage point. Let's take our plane and move it to another spot. We will maybe move it right down here. When we move our plane right down there, it's going to slice out another circle. And again, if we were to look straight down onto the sphere, that circle would produce, that slice would look like a circle of a different radius. We'll call this line up here that we did R1, a circle of radius R1, radius R1. Here we have a circle of radius R2, and this is radius R2. Now you can imagine if we took our plane and took it to a different height. Let's say right here. When we are at that height, our plane slices through the sphere, producing a different circle as we look down from the top of the sphere. And this circle, I'll just say this is a circle of radius R3. And finally, let's just take our plane and slice it right through the midsection of the sphere. And when we slice it right through the midsection of the sphere, notice you get another circle of another radius. And this was the circle of radius R. So each time we took a slice, we generated another circle. Each of these circles that we generated is a trace. And these traces were taken as the set of points at which the surface, our surface, the surface of a plane that is parallel to some other plane, so here's another plane that it's parallel to, that trace is comprised of the set of points at which the surface intersects this plane. Let's take a cylinder. Here we have a cylinder whose central axis is parallel to the z-axis in this XYZ rectangular coordinate system. Well, let's start off by taking a plane. In fact, let's just take the XY plane. If I take a plane parallel to the XY plane, and I put that at the value of z equals 0, notice that plane slices right through the cylinder, producing a line of intersection. And that line of intersection we call a trace. This trace corresponds to the value of z equals 0, where z is our plane positioned at the value z equals 0. Let's go ahead and move this plane from the XY coordinate system, from the value of z equals 0. Let's now take a different plane. We'll take the plane, put it on the positive z-axis. We'll just call this coordinate z1. Let's take this plane to be the plane z equals z1. With that plane intersects the cylinder, and when it intersects the cylinder, it produces a line of intersection. This line of intersection is a trace. And this is the trace for the value z equals z1 from the plane z equals z1. Let's take another plane. Let's take the z equals z2 plane. If we have the z equals z2 plane, once again, when it intersects the cylinder, it produces a line of intersection. And that line of intersection, once again, is another trace. That trace is the z equals z2 trace. Well, if we look down on these traces from the positive z-axis, looking down, those traces would be circles. And in the case of this cylinder, all those circles overlap. Here's our perspective looking down from the positive z-axis. So this could represent the circle z0, or the circle at the value of z1 at the value of z2, so on and so forth. So the cylinder produces traces that are circles in the xy plane. And that's pretty interesting how one shape can produce a particular curve, and in this case, a curve we recognize in the xy plane. A trace could be with respect to any of the coordinate planes. For example, if we have our x, y, z coordinate system, and this time let's have a cylinder. Let's have a cylinder that is parallel to the z-axis. Here's our cylinder. But now let's take a plane that is parallel to the xz plane. So this would mean that we're going to have a plane at some value of y. Let's say that value of y corresponds to y equals, I'll just call this y1. So if that value of y equal to y1, our plane would slice through the cylinder. So let's sketch the plane. Here is our plane, and our plane slices through the cylinder. So these lines that are produced, this line here is a trace, and this line here is a trace. I'll go ahead and turn that dotted line into a solid line so it's just more clear. And now let's look at these traces. Let's project these traces onto the xz plane. So I'm going to do that just by copying and pasting these lines. If I were to project these lines onto the xz plane, it looks something like that. Okay, so there's a lot of things here, and you might not be able to see what that looks like. So let's take another vantage point. Let's take the vantage point in which we are just looking at the xz plane. So in looking at just the xz plane, we have the z-axis going up, the x-axis is going to the left, and we are looking down from the positive z-axis. That would be from this direction here if we were to position ourselves here and were to look down from the positive z-axis. So in looking down from the positive z-axis, you would see your cylinder. The cylinder would just look rectangular. But when we passed our plane through, here is our plane. When we passed our plane through, our plane intersected the cylinder right on this left portion and right on this right portion. These two lines produced are our traces. And these traces correspond to the plane y equals y1 as we described in our previous graph. Now imagine taking that same cylinder we'll resketch the cylinder, it's good practice. Imagine our same cylinder. And now imagine that we are going to take our plane and produce a number of different traces. And we're going to look at the traces projected onto the xz plane. Here is the plane in which we have parallel to the xz plane. this plane will correspond to some value of y. We're going to move this plane down. So we're going to start with the plane, let's say, near the top of our cylinder. And actually, let's do the plane right at the top edge of our cylinder. So right at the top edge of our cylinder, we're going to have a trace. From this picture, we're going to be looking down from the positive y-axis. The z-axis will be vertical, the x-axis will be going to the left. And that trace that we just created, this line right here, right on top of and parallel to the z-axis, we will call this line the line produced by the y equals y1 plane when that plane intersects our cylinder. So we will call this the y equals y1 trace. Let's take our plane and move it to a different value of y. So, and in fact, let's create some even distances we're going to move down. So we will have, I'm going to put some tick marks here, here, here. So we're going to do a few more planes. And let's just, for reference, project those tick marks here, here, and here. Oh, we might as well put some down here, 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 and here. So those tick marks are there just for reference. Now let's take our plane and move closer to the y equals 0 value. So I'll move our plane right about here. And when I move our plane right there, it intersects the cylinder. And when it intersects the cylinder this time, it's going to intersect the cylinder on two sides. There's going to be two lines of intersection, one on this side of the cylinder and one on the opposite side of the cylinder. Those are two new traces produced by the, we'll call it the y equals y2 trace. If we were to look in our coordinate system here on the right, that might look like this. These two lines correspond to the y equals y2 trace. Well, let's continue moving our plane. Let's move it to the next set of marks. When we move it to the next set of marks, our plane intersects the cylinder right here and right here. And that intersection produces another trace. So we will call this the y equals y3 trace, and that's going to be here on this side and here on this side. Let's just do two more really quickly. So if we then move it down to the next set of lines, we are going to get a trace that looks like this, and this on the other side. And when we project onto the XZ plane, that XZ trace looks like this. So notice how we keep taking our plane that's parallel to the XZ plane, and we end up getting a graph. We end up getting some lines of intersection. And those lines of intersection that the plane makes with the cylinder, those lines of intersection are what we call traces. In this case, we've just sketched some traces of a cylinder.